Alright, we're taking a quick preview look at AI Builder 2 from TinMan Systems. This is a Windows-based application running on Windows Vista or later. We're looking at the main interface now. Point out a couple of key areas. You've got a ribbon bar across the top with all of the commands relative to what you're working on at the time. You've got a utility components palette with 5 separate categories of components to build your system. You've got your main interface or work area here, and this is where you add modules and connect those modules and eventually go inside those modules and build out component structures using the components available to you in the palettes. To the right here is your system modules tree structure that essentially will track with you and provide a drill down tree for navigating your structure. You also have a system view, a mini view map that'll follow you and essentially give you a way to navigate and move to different components within your structure as you build out that system. And when I go back to the system view mode, I'm looking at just the modules that you have within the larger structure. And if I double click on those modules, I enter into the component level structure of that. You can see in module 2 we don't have any components yet, but we certainly could add some and begin connecting and connect with the other modules through these connections. And eventually you'd connect to the outside world, and that's your inputs and your external outputs. But taking another look here, the interface allows for a familiar drag, drop, connect, and configure approach. And once things are connected, even before they're connected, you can always simulate, and given the simulation speed, essentially this system is executing cycles in its relative order, execution order, 15 times a second here. And but you can change that speed. You also have down here a kind of system feedback, execution feedback, and some various results that the system itself might want to communicate back to you. But that's the interface, and we'll drill down on some of these on how to build a system, what these components, how to use the components, and how to navigate throughout the environment itself. Each of the individual components in AI Builder has a specific set of inputs and outputs. I've put about 10 of them on the screen. Just selected a few that would best illustrate how unique each of these components are. Now the inputs on each component are to the left, and the outputs come out of the right side, and they are labeled as to what that input or output is, and usually give some indication of what kind of data is required or produced by that input or output. And the connections themselves, just a right click on the component, would take that value, connect it to another component, and then that component here can then connect to another component. Outputs can connect to multiple components, and that's how you would build your structure. But the idea is that as you drag components to the screen and connect them, you are still given an indication, a visual indication as to what the component is by the symbol that's consistently carried across from the icon, and the labeled inputs and outputs. For instance, here's an FFT that takes in a signal, double array, a sample rate, and provides the bin count, a spectrum double array out, along with the bin size, peak and low frequencies, and the Nyquist frequency. And each of these, some of the components are very simple, like an equality check, where you drag whatever number of inputs you want, and it'll check to see if it's equal to a certain value, and give you the number of items that satisfy that. Some are very simple in that way, and others are a little more complex. Some are visual components. For instance, the integrated column chart would just be something you drag to the screen to watch a value. You just drag here to this open space, and that value then would be plotted as you simulate and move through the simulation. Others are a little more let's say visually interesting, like an LED display, which are used really to produce and analyze the type of output that might be used in some robotics elements. Here is a 7-segment LED display. So some of the components themselves are a little more visual in nature, but still the visual clarification as to the type of input and what data is required is made very clear. There are roughly 85, 86 components today. We're adding components very quickly, and we would expect that to grow significantly. But that is our rundown of components. One of the strengths of TinMan systems, and in particular the legacy technology AI Builder 1, is in neural networks. And so that's obviously a key part of AI Builder 2. AI Builder 2, as I think we've mentioned, as 85 components that can be used in systems that are created within the Builder environment. And one of those is a neural network. And this is a self-structuring, self-configuring neural network that takes in a set of feature vectors. We're just going to import some patterns here. There's a wizard dialog box that allows you to set the correct parameters in terms of how to read that data file. We're going to bring in a data file that has a number of classes and feature vectors, 100 feature vectors with 4 attributes. We're going to bring that in. You can see that the component has already exposed the 4 attribute inputs, sepal length, width, petal length, and width, and the 3 classifications that those attributes result in. And it says 4 inputs, 3 outputs, and 10 processors. So internally there's a structure of 10 processors that are going to provide the computational analysis. And so at this point, let's show that vectors list. So here is the feature vectors pane. Here are the 100 feature vectors, and the ones that are already in a state of computation where the target output is actually the classification required, then we have learned it already. But let's go ahead and just erase, reset that, and learn. And it gives us kind of a status. You can see some real-time updates of the component itself, and we're up to 92, 93, 94. Typically, a set like this would take maybe 30 seconds. That was 13 seconds. And you can see we have a blue indicator light that says that the target output and the actual output are indeed the same for that particular feature vector. And so this one's learned. And the one thing that we can do now is when we select the feature vector itself within the worksheet pane here, it actually sets the input values of those attributes to this feature vector that we've selected. And now if I just use my arrow down key and I move through that, you can see that the input values are set to 5, 3.2, 1.2, and 0.2. And as we move through here, and you can see the output calculation here of those individual classifications. And if we wanted to kind of just see what those are, we can expose those through a value window, just so it kind of blows those up for us. And we can also, let me just arrow through those as we watch those values change. Now the other thing that we can do is we can utilize one of the utility components, which is a format, an action format. And what I'm going to do is just grab this and associate it with that, so that when that is the winning vector, let's just see, make these zeros and ones, that will be blue. And let's just add 2 more here. Let's see. There we go, and we'll do that one, and 1 more. And so essentially what these format components do for us? Is it just a visual aid that allows us to see the change in value? I'm just going to arrow through these, and we should see those change as to the one that's actually the target output. And this is a great way to kind of test and walk through your feature vectors to see which of those winning classifications have resulted from that computation. The modular architecture of TinMan AI Builder 2 enables the development of some fairly complex and sophisticated decision-making systems. And oftentimes you'll find that those systems are comprised of many, if not potentially hundreds of components. Here we're looking at just two simple modules within a particular system. And if I double click on this one, we can see that this module contains somewhere on the order of 40 or 45 components. And we've got some visual elements here, we've got some graphic backdrops, and some displays. And you can see that certainly as you're building it, you follow along, you know where you're at, but over time these can be a little intimidating, and but they are necessary to build real-time, accurate, and comprehensive decision-making systems. But when you're working with these, it's nice. Let's just get this simulating. It's often nice to be able to simplify what you're looking at, and so here we're just simply bringing in 5 random values. We're doing an OR check on input from the outside world or a button press to enable these random number generators. We're showing what those numbers are. We're analyzing these, crunching these for some combinatorial analysis, and then presenting these out to a display or data reporting kind of an interface with different types of components that are pretty easy to use. I won't explain the use of each individual one. The point here is how we simplify the view. And so, in essence, we're looking at an area which data production, data analysis, and data reporting. And so what I'd like to do is just really kind of, now that I know how I have this arranged and the way I want it, I'm going to go ahead and just consolidate all of these components here into a single element. Here, I'd still like to see the output, the data windows, and you can see we have components 13 in here in this data production box, and you can see how the connections are automatically recomputed, if you will, and visualized in such a way that it's as if this is the component that is producing all of that. But so let's go ahead and do this to the data analysis section as well, and let's have these be consolidated into a smaller, more manageable area. And let's see if we can get this to where we need it to be. Okay, so now we've got a data production box, a data analysis component, and now we're just going to do the same down here to our data reporting area, and we're just going to do consolidate elements. Looks like a couple escaped here, but when you do that, you just do a right click on the box here, and you can consolidate any element by just simply dragging a right click from that graphic element to the component, and we'll just pull it right in within that simplified structure. And so now we've got a lot more manageable interface. And so in working with this, once we have our system doing what we think it should do, and we're happy with that, even if we're not, sometimes it's often good to just reduce those to a more simplified view. Now, the good news is that if we were to let these, let's release these, we didn't affect the actual original positioning. And so we don't have to worry about going back in and setting things back up the way we understood them when we first created it. And so that's a real nice thing if you're continuing to work with the system. Now you will have to reposition these boxes, but that's designed that these are fewer than the components. There's another way we can simplify this view, and that's just through a simple reduce all of these. And so instead of showing the individual components with their inputs and their outputs, what I'd like to do is just show that symbol there with all of the inputs coming into one single input and all the outputs going from one single output. And so we do that by simply reducing all. And so we get not as simplified of an interface as we had when we consolidated these, but we get one where we can still see each individual component, but it's treated as if it has only one input and one output. And in some cases, that's the best way to get things done. You can still see we understand what the functionality of the component is, but we have a more simplified view. One of the ways to optimize the development of your AI structure is to not just take data in from your spreadsheets, but also to have the simulator produce the data for you. And oftentimes it's helpful to have that data be random or partially random. Here what we're doing is we're showing 4 key components here. The random number generator component right here, the dynamic simulated value component, the quantity diminishing component here, and let's just reset that so we can see that quantity diminish, and then the SimInfoLocal time component. These are helpful if you, the random number generator, if you want a random number each execution cycle. We're just taking one from 0 to 10 and we're producing a pre-built a bit pattern that drives this 7-segment LED. Down here we have dynamic simulated values that start out at a value and then they change by a random increment that you can customize. And then we're plotting that as these values are created. Over here we have a quantity diminishing component. Now this is a great component to facilitate simulation where you need to function on a proxy resource for any external consumable resource that has quantity and it can change in value, such as banking levels or fuel levels, biological capacity, hydraulic systems, food and water. And so this is really helpful if you're trying to drive this, and you can increment this back up and automate the management of that diminishing resource. And then the SimInfoLocal time really just supplies all data members of the local time down to the millisecond. This can be useful if you're trying to augment outgoing data on specific events. Working with spreadsheet data directly is easy with AI Builder 2. Here we just have 2 components, a CSV data input component and a CSV data output component. When you drag these to the screen, they're initially unset with the number of columns. Specify the data file and it will automatically create these outputs and name them according to what's in the data file. CSV data output simply structures itself according to the inputs you create, and it automatically populates the data file line by line as you complete the simulator. All we're doing here, we're going to continue to write data to this file from the input. We're going to disable that writing process when we've reached the end of the file. There are 58 rows here. We're also going to do some processing of 2 of the data elements that we get out of that. We're going to multiply the values, take the square root, and insert that line by line here with the associated data row. And we're also going to get the information about the simulator count. Let's just go, and we'll just start, and it should get right to row 58. And there we are, and we're done. This is no longer writing, although we see cumulative cycles continuing to go. It's not writing anymore. So we'll stop and we'll take a look at the files.